My name is Karen Daly and I teach mathematics at DKIT, a third level college in Ireland. This video was produced to further assist my first year computing students with their mathematical studies. At the end of this tutorial, you should have gained an understanding of solving the shortest path problem using Dijkstra's algorithm. Enjoy! In this tutorial, we're going to solve the shortest path problem using an algorithm known as Dijkstra's algorithm. Now, there are more algorithms than just Dijkstra's algorithm that does this, but for this tutorial we're going to concentrate on the use of Dijkstra's algorithm. Now let's move this up here a little bit and look at a typical shortest path problem. Here we have A, B, C, D, all the way down to G are computer terminals, with the figures displayed representing the time taken in seconds for data to travel from one computer to another. So if we look at the diagram, here you have computer A, and here you have computer B, and the time taken for data to flow between A and B is typically 8 seconds. Now the question that we're asked is, using Dijkstra's algorithm, so there's Dijkstra's algorithm, find the shortest path from A to F, clearly displaying the implementation of the algorithm. What is the length of this path? So we want to find the shortest path between A and F. So we start at A and we want to end up at F and find the shortest distance between the 2 points. I'm going to show you the implementation of Dijkstra's algorithm on the actual diagram that's given to you here at the top of the page. So in an exam, if you're asked this question, what you should do is take the diagram from the page on the exam and rewrite it in your exam script and show then the implementation of the algorithm on that diagram. So let me begin. I start at A because that's the beginning of my journey, and for the algorithm I'm going to label A with a value 0 because I've travelled 0 distance at this stage. I'm starting at A. Now what Dijkstra's algorithm does is it's a search, and it searches beginning at A out from A one step and finds the shortest path from A. Now it'll do a search of the two routes AE and it'll come back with a value 10. It'll search the route AB and it'll come back with a value 8. So obviously AB is the shortest of these two routes, so what it'll do is it'll travel down this route here. Okay, and it'll end at B. So what I'm going to do is I'm going to label B with the value that it takes to travel between A and B, and that is the value 8. I'm going to put a little 1 here to show that this is the result of the first search made by the algorithm. You got to here. Sorry. Now the next stage is that the algorithm will do its second search. So it'll look out from A again, and the only route that's available to it there is AE, which is a distance of 10. And then what it'll do is it'll look at all the routes out from B, right? Now it'll take the weighting of 8, which is the distance travelled from A, and look at all the routes out from B. So it'll look from B to C, which has a combined weight of 8 plus 3, which is 11. It'll look from B to D, which is a combined weight of 10, and it'll look from B to E, which has a combined weight of 8 plus 5, which is 13. The algorithm chooses the shortest value and the smallest value. And the smallest value, there are two of them. AE is 10, but also ABD is 10 also. Now, it makes no difference which of the two you choose. So let's say I'm just going to choose the BD one. So it's going to travel along here, right? And when you get to D, you're going to have a weight now, carrying a weight of 10. So I'm going to label D with the value 10. I'm also going to put a little 2 on the 10, right? Because that's the result of the second search that the algorithm has done through the diagram. Now on the third search, the algorithm looks out from A, B and D, right? And calculates the combined weight out from there and chooses the smallest one. So again it has AE is 10, right? It has BC is 11. It has BE is 13. Then it has DE, which is 15, DF, which is 20, DG, which is 10 plus 5, 15, and lastly DC, which is 10 plus 2, which is 12. Now obviously the smallest of these is the one that was the same weight as the last one, the AE. So it'll travel the shortest distance again, so it'll go A to E, so I label E, right, with the value 10, 1, 0, okay. And I'm going to put a little 3 here also to indicate that that's the result of the third search. Now the algorithm repeats the process again. Now there are no more choices from A, right, because all have been exhausted. From B, there is just one choice, that's the route BC. And BC has a weighting of 11, so that actually is looking good. From E, there are two choices. There's only one choice as well, sorry. It's EF, and that has a weighting of 23. So that's actually too big in relation to the BC option. We're looking for the shortest distance. When we go out from D, we can go from D to F, which is a weighting 20, D to G, which is a weighting 15, and lastly D to C, which is a weighting 12. Now obviously 11 is smaller than 12, so the next choice that the algorithm will make is to travel, down this route here from B to C. When it moves from B to C, it has a combined weighting of 11, right? And that's going to be my fourth result. Now the algorithm begins again, and it looks out from C, and it only has one choice, CG, which has a combined weight of 11 plus 2, which is 13. Then out from D, there are two options, DG, which has 10 plus 5 is 15, and DF, which is 10 plus 10, which is 20. And it has one option from E, which is EF, which is 10 plus 13, which is 23. Now it chooses the shortest of all of these, and again the shortest of all of these turns out to be CG. CG, along here, has 11 plus 2, which is 13. So I put 13 as a label on G, and that's my fifth run of the algorithm. Now the algorithm begins its search again. In this case it searches out from E, and EF is 10 plus 13, which is 23. It searches DF, 10 plus 10, which is 20. And lastly, the only other search it has open to it is GF, and GF is 13 plus 9, which is 22. It chooses the smallest of these three options, and the smallest of these three options is DF, so I'll put that in. DF, which is 10 plus 10, which is 20. So I've now arrived at my destination, which is point F, on the sixth search through the diagram. Once obviously I get to my destination, which in this case was F, the algorithm stops. And now I have the solution. To get the solution, I'm going to backtrack from F, right? So F had a weighting of 20, and if I backtrack here, right, F 20 minus 10 will bring me back to D, which is 10. Backtrack here, D back to C, right? B, 10 minus 2 will give me the weighting 8. And again, backtrack here, 8 minus 8 will give me 0. So to write down the solution, I firstly have to identify what my shortest path is. So I'm going to write it here. The shortest path I've identified as being, it starts at A, and then it moves to B, and then it goes to D, and lastly it goes to F. So that's the answer. The shortest path is that path there. And if I want the length of this path, all I have to do is I have to add up the figures from A to B, was 8, plus from B to D was 2, plus from D to F is 10. So the answer is 20. Or I can just take it from the label that I ended up with at F here. You can see that it's 20. So the length of that shortest path is 20. And putting in the units, it would be 20 seconds. SECONDS. So it would take 20 seconds for data to flow from computer A to computer F. Okay, what I'd like you to do now is to attempt this exercise yourself. Take out a pen and a paper and copy down this diagram here that you see on the screen and answer this question. Using Dijkstra's algorithm, find the shortest path from E to I, showing clearly the implementation of the algorithm. So pause the video now and give yourself some time to attempt this. And when you're finished, turn the video back on and I will go through the solution with you. Okay, we need to use Dijkstra's algorithm to find the shortest path from E, so let me highlight E, to the point I, and I is here. Okay, let's start. So the algorithm begins at E, so what we do is we label E with a 0 because that's where I'm beginning from. So that's the distance I have travelled so far. Now what the algorithm does next is it looks out from E and it chooses its shortest route. Now it has a few options open to it obviously. It has the option to F, which has a value 3, the option to G, which is 4, the option of travelling to B with a distance 9, C a distance 10, and lastly D a distance 2. Obviously the algorithm chooses the shortest path, so obviously it's going to choose this route here, ED. So let me highlight that for you, ED. When it arrives at D, it has travelled at a distance 2. And I'm going to put a 1 here to show that that's the first point that the algorithm arrives at as it works its way through this particular network. Now because it hasn't arrived at I, it will continue searching, except this time it will search out from E and from D also. So again, as it searches out from E, it can go to F with a value 3, G 4, B 9, C 10, and then it'll also search out from D. Now D, as it searches out from D, it'll combine the weight. So DC will have a combined weight of 5 plus 2, which is 7. And DG will have a combined weight of 6 plus 2, which is 8. Now again, the algorithm chooses the shortest route, so the shortest route here is going to be EF from all of them. So let me highlight that for you. So it arrives at F, and F is going to be labelled with a 3, and that's going to be the second place it arrives at in its search. Continues on from here. Because it hasn't arrived at I, it will now search out again. This time it will search from F, E and D. Right? From E it can travel to G by a distance 4, it can travel to B via a distance 9 and C via a distance 10. It can travel from F through a combined weight or distance of 4 plus 3, which is 7, and also it can travel from D to C with a value 7 and D to G with a value of 8. Again, it chooses the shortest path, and the shortest path in this case is, let me highlight it, E to G, and E to G is now going to have a value of 4. So that's going to be the third place the search arrives at. Still hasn't arrived at I, so it repeats this again. So it searches from. Now it can't search from F because there's nowhere to search from, or to, sorry. It'll search from E, and again it can go from E out to B through a distance 9. It can go from E to C through a distance of 10. Now it can also search from D, and from D to C it'll have a distance of 7. From D to, and that's the only one because G has already been arrived at. It can also search out from G, right? So the first search with GC would have a combined weight of 12. GA would have a combined weight of 12 and GH would have a combined weight of 9. Again, it will choose the shortest of these, and the shortest of these is DC. So let me highlight that, DC, and DC has a combined weight of 7. So that's going to be my fourth destination point on this with this search. So not having arrived at I, it will search again. So it will search out from C, 7 plus 7 is 14, to B, right? So to B, it'll have 14. 7 plus 12 is 19 over to A. Won't go to G. Then there's no place to go out from D. There's one place to go out from E, and that's to B. EB as a distance 9. And then from G itself, it can go from G to A with a distance 12 and from G to H with a distance 9. Now, there are 2 9s that it can possibly choose from. It doesn't matter which of the 9s you go for, either of the 2 will do. So I'm going to choose the path EB. So let me highlight that. So EB, all the way up to here. It comes up to here and it has a 9. All right. So I label this with a 9, and this is my 5th value. Still not having reached I, it'll research again, and the next shortest path that it will choose will be the other 9, the GH. So let me highlight that. So G to H, and it'll search, and it'll come up with a 4 plus 5 is 9. So that's going to be my 6th value of point visited, right? Still not having reached I, it'll do a search out from here, right? So let me highlight these searches for you. The first search will be maybe from H to A, has a combined value of 9 plus 3, which is 12. If I was going out from G, it could go from G to A, and again it has a combined value of 8 plus 4, which is 12 as well. Okay. From C, it goes out to A, but this has a combined value of 12 plus 7, which is 19. Okay, and also you could go out from B. It can go from B to A, which is a value of 13, and it can go from B to I as well, with a value of 12. Now at this stage you can see there are 3 routes that have the lowest value, which is 12, right? You can choose any of the 3, or you can do them in any order you like, but you still end up with the same answer. I'm going to choose the option BI, because I know I is the destination I want to arrive at anyway, so it'll just mean that I get there quicker. It won't change the answer, obviously, to the question. So here I am, I've arrived now at I, and it's 9 plus 3, which is 12, so I label I with the 12, and that now is my 7th point that I have arrived at. So I've arrived at my destination. So if I want to write down the solution to this problem, the solution of this problem, I have to show what the shortest path is. So the shortest path, right, is, okay, let's see what it is. If again, I was where I arrived at, so if I work backwards, right, I went from I back to B, 12 minus 3 is 9. And again, if I work backwards, right, 9 minus 9 is 0 back to E. So the shortest path turned out to be started at E, I visited B, and then I ended up at I. Okay, and if I want the length of this shortest path, I can add the 2 values together, or I already have that done. It's the value that's in my box here, it's 12. So the length of my shortest path is 12. If we're talking seconds, you can put down the units, it's 12 seconds. Dijkstra's algorithm is a greedy algorithm and is not necessarily the most efficient algorithm. There are other algorithms out there that would do the job a little bit more efficiently from a programming point of view. But for this course, we're just looking at this particular algorithm to solve the shortest path problem.